Welcome back to This Explainer. Today, we're diving headfirst into a century-old debate that has literally torn the scientific community in half. We're looking at a single, monumental discovery. On one side, scientists argue this breakthrough saved billions of lives. On the flip side, their colleagues passionately argue that it unleashed the absolute horrors of modern warfare. This is the story of an unresolved civil war in science. How do we judge a discovery that gave us both bread from the air and gas for war?
So to really grasp why scientists are still fiercely debating this today, we kind of have to start with a deceptively simple question. Where does the bread on your dinner table actually begin? You ask a baker, they'll say flour. A farmer, they'll point right to the soil. But scientists, looking at the fundamental building blocks of life, give a totally different, honestly surprising answer.
They'll tell you it's the air. Yep, it begins right in the sky above us. And that's because the absolute fundamental building block for crops, wheat, rice, corn, the whole shebang, is nitrogen. Without nitrogen, plants just grow weak, yield less, and basically fail to form the grains we actually eat. Put simply, no nitrogen, no bread.
Now this brings us to a massive crisis that had scientists back in the late 19th century in an absolute panic. See, atmospheric nitrogen is incredibly abundant. It literally makes up nearly 3/4 of the air we breathe, but it's chemically locked up. Those two nitrogen atoms bind together so tightly that plants just cannot break them apart to use them. Imagine having a massive planet-sized vault of food directly over your head, but possessing absolutely no key to open the door.
For centuries, humanity was basically scraping by using whatever limited keys nature provided: manure, compost, mined natural saltpeter, and nitrogen-fixing legumes. But for a rapidly exploding global population, relying purely on these traditional sources created a terrifying bottleneck for global food production. Scientists were desperately debating how on earth we were going to avoid mass starvation when those natural supplies inevitably dried up. The world literally needed a chemical miracle.
Well, enter the two men at the absolute center of our debate, Fritz Haber and Carl Bosch. The scientific community at the time already knew the theoretical math. They knew that if you could somehow force nitrogen to bond with hydrogen, you'd get ammonia, a form of nitrogen that plants can actually absorb. But pulling off that chemical reaction, it was considered nearly impossible. Haber and Bosch, though, decided to take on the immense challenge.
They came up with a process involving 3 deceptively simple steps. Step 1, isolate atmospheric nitrogen. Step 2, combine it with hydrogen. And step 3, which is the brutally difficult part by the way, apply extreme heat, massive pressure, and a specific iron catalyst to force them to synthesize into ammonia. Fritz Haber actually managed to demonstrate this in a lab. He proved that, by actively fighting the natural stability of nitrogen under immense pressure, you could produce ammonia. He had finally found the key to accessible fertilizer.
But what makes this partnership so fascinating is the sheer contrast between the two men. Haber achieved his breakthrough in a highly controlled lab, making, well, literal drops of ammonia. But lab drops aren't going to feed a planet, right? That's where Carl Bosch steps in. Bosch pioneered industrial-scale engineering. He designed these unprecedented, massive, highly pressurized reactors that wouldn't just blow up under the intense conditions. Haber found the chemical key, but Bosch engineered the massive factory machinery needed to turn those tiny drops into thousands of metric tons.
Now, for the scientists who defend Haber in this ethical debate, the result of this process is their ultimate trump card. The Haber-Bosch process paved the way for mass-produced synthetic fertilizers. This wasn't just a step forward in chemistry, it was a total game changer, an agricultural miracle. Suddenly, the limitation of natural soil was completely removed. We could inject the earth with exactly the nutrients it needed right on demand.
It's an elegant chemical chain reaction that literally pulls bread from thin air. You start with the atmosphere, extract the nitrogen to make ammonia, turn that ammonia into fertilizers, which leads to massive harvests, and finally, the bread on your table. By using these synthetic fertilizers, farmers were suddenly able to drastically multiply crop yields on the exact same plots of land they've been farming for generations.
And the scale of this achievement? It honestly can't be overstated. Combined with modern farming tech, this synthetic nitrogen has helped feed billions of people. Literally, billions. To put that into perspective, without the Haber-Bosch process, it's estimated that nearly half the world's current population wouldn't have enough food to survive. For this, the scientific community initially celebrated them, seemingly cementing these two as undeniable heroes of human history.
But here is exactly where the debate violently fractures, because the scientists who condemn Haber point out that the exact same nitrogen chemistry they unlocked has a much, much darker face.
It is a horrifying duality.
fertilizers for growing life on the farm versus explosives for destroying life on the battlefield. You see, ammonia isn't just good for feeding plants. That exact same chemical breakthrough is the fundamental chemical basis for manufacturing high-yield military explosives, things like TNT and artillery munitions. Practically overnight, the serene farm and the bloody front line were drawing their power from the exact same scientific vault.
For Fritz Haber, his legacy turns pitch black during World War I. He didn't just passively sit back and watch his discovery get used for artillery shells. No, he actively spearheaded Germany's poison gas program. He took his absolute genius for chemistry and intentionally turned it into an instrument of mass horror, personally overseeing the deployment of deadly chlorine gas in the trenches. He famously argued to his peers that in peacetime a scientist belongs to the world, but in wartime he belongs to his country. His fellow scientists were utterly appalled, triggering the bitter ethical debate that still rages today.
This moral friction reached an absolute boiling point in 1918 when Fritz Haber was awarded the Nobel Prize in Chemistry. Think about that for a second. He received the highest possible honor in science for a discovery that fed the world while simultaneously being internationally condemned for unleashing toxic gas and agonizing death. His Nobel ceremony wasn't a celebration, it was a battleground. Prominent scientists actively boycotted the event, flat out refusing to even stand in the same room as a man they viewed as a war criminal.
So we are left with this impossible duality that keeps ethicists arguing in circles. On one side, we have the savior who solved an agricultural nitrogen crisis and fed billions of people. On the other side, the destroyer who pioneered the use of poison gas and armed a devastating world war. In the scientific community, this remains the ultimate deadlock. How do we possibly reconcile the legacy of a genius whose work brought both immeasurable human survival and unforgivable destruction? Can those two sides even be weighed against each other? What this whole debate ultimately reveals to us is the chilling neutrality of the technology itself. Bread versus gas. The chemical process is completely neutral. It doesn't have a conscience. The very same nitrogen, harvested from the atmosphere, can become life-sustaining bread on your table, or it can become lethal explosives in gas. Science merely unlocked the door. It didn't tell humanity what to do once we walked inside.
So, I'm going to leave you to settle this scientific debate for yourselves. Science and brilliant technology hand us the keys to immense, almost godlike power over the natural world, but the science itself lacks a moral compass. The choice of whether that power becomes a tool for salvation or a weapon of devastation is entirely up to humanity. When we unlock the next massive technological vault in our own time, how will we choose to use it? Thanks for joining me for this explainer.